Okay, we have example 15 up next. So an architect has designed a new open plan office building using two identical parabolic support beams, spaced 25 metres apart as shown below. So that means this wee bit here is 25 metres apart. The front beam relative to simple axis has the equation that the inhabited part of the building is to take the shape of a cuboid, which you can see in the diagram, by considering the point P in the corner of the front face of the building and show the area is given by that. Okay, so we have this point P. Now, key to this is don't overcomplicate it. What do you know about any point? You know it takes the form x, y. Okay, so what does that mean? That means that we've gone along x and we've gone up y. Now, we want to find the area of this full face. So if you think about it, if that's x, then that must be 2x. Okay, so the area is length times breadth, which is 2x times y. Okay, because all we know about point P is that it is a point, so all we know it takes the form xy. So if that must be from the origin, because here's your origin here, as it said, go along x up y to get to that point P. So the area of the full thing is 2x times y. Now, what do we know about y? Well, because our answer's only got x in it, we know that y is in fact that. So we have 2x times y, which is 27 minus x squared. If we multiply that out, we're going to get the answer that's directly above. So a wee bit sneaky, okay, in terms of the way it's asked, but it's just trying to really simplify things down. What do you know about a point? It's a point x, y, and we have a relationship between x and y because obviously we're working with graphs. Then part B, we have this answer. We're just going to sit and churn it out. Find the maximum volume of the inhabited section of the building, and we know the area is that. So what we want to think about is to get the volume. Okay, so maximum volume. We're going to, well, we can figure out the start or the end, to be fair to you, but we could just do it now and just times by the 25, because volume is area times height. Or we could do it at the end and just remember times by the 25. It's kind of up to you. A lot of these questions tend to be calculator. So 1350x minus 50x cubed. So that is our volume. So we're going to try and find the maximum volume. Again, you could have got the maximum area and then times it by 25 to figure out the maximum volume. It is up to you. Right, we're going to differentiate it. Now you could do dv by dx, or you could do v dashed of x. I'm going to set it equal to 0. I'm going to take that over. Obviously, it's plus or minus 9. We are working in, a real life context here, so x must be 3. Okay, so obviously we know we get two answers, plus or minus 3, but it's not going to be the minus because we're dealing with a building, really. Right, nature. Okay, we're just going to look at 3. Again, make sure you're consistent, so I did dv by dx. Oops. You will not get marks if you write dy by dx or f dashed of x, because the question is talking about volume. Right, so if we sub 2 into here, again, you just want to know, is it positive or negative? We are looking for a maximum, so we're expecting to get a maximum. But always double check, because if you don't, it means that something's gone wrong. Okay, so therefore, we do have a maximum at x is 3. So our volume, we're going to sub it back into our formula for our volume. So 1350 times 3 minus 50 times 3 cubed. (2,700 meters cubed). Okay, so I worked out my volume using my formula for area because I knew the length was 25. We differentiated it, we used an h table to prove it was a maximum, and then we figured out what the maximum value actually was.